Blue Horse Theatre 2025.
Welcome, my friends, to the Blue Horse Theatre. Now playing. Dr. Bradley Lepper presents The Burning Tree Mastodon and Ohio's Ice Age. March 19th, 2025, at 6:30 p.m. Ohio University, Chillicothe. Auditorium, Bennett Hall. Hosted by the Friends of Hopewell Culture, National Historical Park, and Ohio University, Chillicothe.
Foundation on which everything else was built. So if you want to understand the Hopewell, you need to know something about the Adena and how they came about and how they became the Hopewell. If you want to understand the Adena, you've got to understand the Archaic. And if you want to understand the Archaic, you have to understand the Paleo-Indians. And if you want to understand the Paleo-Indians, you have to do archaeology in Asia. So I wasn't going to be doing that, so I wanted to start at the beginning. And my advisor at the time actually advised me against trying to do that as part of a dissertation, because he didn't think I'd be able to collect enough data to write a worthwhile problem, to solve this problem, the limited problem even that I was able to come up with. He wanted me to do something else, and then once you get your PhD, then you can go study Paleo-Indians. Well, it turned out that didn't happen, so I'm glad I did what I did and spent an extra year and a half in grad school studying Paleo-Indians because I was trying to collect all the data I could. But finally wrote a dissertation that got me into where I am now, got me my PhD at the Ohio State University. And what's interesting is tonight we're going to talk about a Paleo-Indian site. I didn't know it at the time, but it'll all become clear, that I did get to excavate while I was working for the Ohio History Connection as the curator of archaeology for the Newark earthworks in Flint Ridge. So it makes you wonder, was it fate that I got this job just to be in the right place at the right time to be able to excavate this mastodon? I don't know that I believe in fate, but it sure did work out pretty fun. I have a whole 45-minute presentation about what I did basically in 2 days. So I'm gonna flesh it out though with the research that happened after that. But yes, this excavation took place entirely in 2 days, not by any choice of mine. I'm getting ahead of the story.
The 1989 discovery of this giant, ancient, elephant-like creature opened an unprecedented window onto Ohio's Ice Age. Archaeologists, biologists, and geologists studied the mastodon's nearly complete remains, including its last meal, and other Ice Age animals and plants. This presentation will describe their findings and address the question of whether ancient human hunters or environmental changes drove mastodons into extinction. Dr. Lepper earned his bachelor's degree from the University of New Mexico and his master's and PhD degrees from the Ohio State University. His primary areas of interest include the Ice Age peoples of North America, Ohio's magnificent mounds and earthworks, and the history of North American archaeology. Dr. Lepper has written extensively on these subjects for both technical journals and magazines intended for a general audience. He is the author of the book, Ohio Archaeology, an illustrated chronicle of Ohio's ancient American Indian cultures, published in 2005 by Orange Fraser Press. He also writes a monthly column on archaeology for the Columbus Dispatch. Dr. Lepper was born and raised in northeastern Ohio and now lives in Newark, in the vicinity of the extensive ancient earthworks of that region, with his wife Karen, 2 children, 1 dog, and 4 cats. Dr. Lepper has been visiting professor in the Department of Sociology and Anthropology at Denison University in Granville and the Department of Anthropology at the Ohio State University at Newark.
Oh, yeah, burning tree mastodon. And yeah, that is actually the burning tree mastodon cast on display at an institution I'll mention towards the end of the program. Okay, so this is North America just after or right around 22,000 years ago. That's about the glacial maximum, when all the glaciers were at their maximum. This is a little bit afterwards because the ice is already starting to retreat, opening up that ice-free corridor down which people could enter. People are also probably coming along the coast. But this ice had to start melting back in order for people from Asia to be able to begin the migration into the Americas. So this is very nearly the very beginning, the opening chapter. The environment has changed, it's warmed, the ice sheets are melting back, and avenues of access are being provided to North America. This is when the story begins. If we could go back in time, if we could turn this into a time machine and then put a window and you could look out the window, and we go back 20,000 years, 15,000 years, there would be things that would be familiar. Some of the same plants and trees would be growing around. The biggest difference would be the number and variety of especially big game animals roaming that landscape. It would have looked a lot like the Serengeti in Africa. This is actually not Ohio, but a lot of the animals here lived in Ohio. This is something I stole from National Geographic, and it's supposed to be like the Bering Land Bridge, Thuringia, in Alaska, in the Arctic. So there are species here that we have not found in Ohio, such as the horse in the bottom right-hand corner, saber-toothed tigers, the African lions. Actually, saber-toothed tigers were probably in Ohio because there are fossils of them in Indiana and in West Virginia and in Pennsylvania. So they must have been here. But carnivores like that are really rare. We just probably haven't found it yet. But this is one of the huge difference between then and now. This almost African Serengeti kind of wildlife with giant mammoths and mastodons, giant short-faced bears, giant elk moose, giant beaver, giant almost everything, it seems like. And then the next slide is going to show the same slide, but with all of the animals that became extinct by 10,000 years ago, whited out. So, North America does have a wonderful diversity of wildlife, but it's a pale shadow compared to what we had 15,000 years ago. And this has seemed to have happened sort of right at the end of the Ice Age, which is just the time people were coming into the New World. And there's this big debate in archaeology and paleontology about what caused all these different species to disappear in this window of time at the end of the Ice Age. Some people think the people came in, killed them all. And I always found that really hard to believe, because this is a Clovis point there. It's one we have from the Ohio History Connection collections. Beautiful, killing devices. And these things are found all over North America, and even into Mexico. Well, that's still North America, isn't it? But you have that stone point, as beautiful and as elegant it is, on a stick. And you're going to go up to a mammoth or a mastodon and poke it and think that you're going to survive that endeavor? It always seemed to be really improbable. We know people did hunt mammoths and mastodons with those points, because in sites in New Mexico and Colorado, Arizona, we found the skeletons of mammoths with these spear points stuck between their ribs. So people did at least occasionally do it. But did they do it enough to exterminate that species and many other species? That seemed to me improbable, because there were so many other things they could hunt without the risk of being stomped into goo. And so why would Paleoidians hunt mammoths and mastodons? One thing, there's a lot of meat there. But in almost all the environments that they lived in that were below the sort of tundra environments, you kill that giant animal and all that meat is not going to preserve for very long. So they lived in small bands, maybe a dozen people, maybe a few more, moving around the environment, going to where the food was. And if they killed a mammoth or a mastodon, that would give them a lot of meat. But even if they cut the meat up in strips and smoked it, in Ohio's humid environment in particular, a lot of it would still spoil before they could ever eat it. So this group could not get enough food value from all that meat to make it worth the risk, at least in my sense of what's a good calculation. To risk dying, or to risk, why don't we hunt deer instead? Because they were still here, they were in Ohio too as well. So here's a glacial map of Ohio. So it shows the green is the most recent late Pleistocene glaciations. They came down, pretty far in western Ohio, not so far in eastern Ohio. The arrow points to where the burning tree mastodon was uncovered in Licking County. So it's rapidly, that area would have been very early exposed. So the ice melted back, and some of the chunks got left behind that melted in place and formed what geologists call kettle lakes. Those were important resources for the wildlife as well as for the people. One of those plays into the story here. So that would have been available for mammoths and mastodons just about any time after 20,000 years ago. And this is the Burning Tree Golf Course, because the Burning Tree Mastodon's name comes from the Burning Tree Golf Course. It's no longer named that. They changed the name to Mastodon Golf Course for some reason. But at the time I was there, this was the only part of the golf course that they had created. It was a 9-hole golf course, and they wanted to make it an 18-hole golf course, so they began expanding it in this area here. And they were using a drag line to dig stuff up, the sand traps and stuff. And in one of these, so here's the X that marks the spot where the mastodon was found. That wasn't a pond then. The pond over the millennia had filled in, but they were digging it up with a backhoe, not a backhoe, a drag line, and they found this rich peat in it. And they said, hey, this peat will make great fertilizer for the greens. So they began mining that, piling it up on the edge, and partway through that excavation, the drag line hit something really hard. And fortunately for history, the guy got down off his drag line, came out, shoveled away to try to find out what it was. And in news broadcasts, he said to him it looked like a prehistorical beehive, because the drag line had hit the back of the skull of the mastodon, yanked it hard, broke both tusks off, and broke open the back of the skull, which did look, like a spongy kind of a beehive. But it was not a beehive. It was the skull of a mastodon. And the owner, as anxious as he was to do the golf course, as a kid, was very interested in the Johnstown mastodon, also found in Licking County, which is on display at the Cleveland Museum of Natural History. And he said, this is going to be like the Johnstown mastodon. It's going to be famous. So he calls the Ohio History Connection. Back then we had the other name. And he called the local Licking County Archaeology and Landmark Society. Now, I was employed by the Ohio Historical Society, Ohio History Connection, but I was working closely with the Licking County Archaeology and Landmark Society. And Paul Hogue was the director then. And he and I both, they called the Ohio History Connection, and then the Ohio History Connection calls me. And the guy also called, in addition to the Ohio History Connection, he also called the Licking County Archaeology and Landmark Society. So Paul heard about it too. He calls me. We decided to go out together the next morning. And I have responded to calls for big animal bones before. And it was pretty much always, yeah, that's a horse, or that's a cow. Thanks for calling, could have been something important. And that's what I fully expected. So I did not go out dressed appropriately, let's say. Okay, so here's an aerial photograph, and that's a story in itself. Maybe if you have a question that later, I can tell you the entertaining way we got this photograph. But the ice there is the water that's filled in. They've been digging there for days. The arrow is pointing to sort of the black peat, which is where they were digging when they found the mastodon. And you can see a roof of a backhoe, but even further to the right is actually the drag line that discovered it. They were using the backhoe to sort of scrape away some dirt from around it, or peat, I should say. And this is the first picture I took when I got there. So the steam is rising up from this. All these people are dressed reasonably. Here's the skull. And I'm not a paleontologist. I couldn't tell if it was a mastodon or a mammoth. It looks pretty much the same to that. I'm sure if I'd had a paleontologist with me, he would have identified it. But until I saw the teeth, that's when you can be sure, because the teeth of mammoths and mastodons are really different. And there I am with a big smile on my face holding one of the mastodon bones. When I was much younger, by the way. Yeah, this is 1989. And the temperature is 20 degrees Fahrenheit with the wind chill below 0. And so when I saw this, I said, yeah, that's great. You've got like a mastodon or a mammoth. Can you fill it back in and we'll dig it up in the spring? And he looked at me and he said, no, I want the golf course up and running in the summer. I'm not going to wait. You have to dig it up today. I said, today? We don't have any supplies. We don't have any crew. And he said, okay, how much time do you need? And I said, well, a couple of hours at least. He says, okay, you got 2 hours. If you don't dig it up, I will. And so Paul and I went off in different directions. And this is one of those, it takes a village to excavate a mastodon in 2 days. Because we got a feed mill to donate us a bunch of burlap bags. A moving company gave us a bunch of boxes. The Ohio Vista Connection let us use their flatbed truck. The Licking County School Board had just bought the old Licking County Sanitarium. And they were going to use it for their office building. But they hadn't done anything with it yet. Paul convinced them for them to give us the basement to use the laundry room as a lab and to store the bones there. All kinds of other people contributed. Oh, and the Licking County Joint Vocational School donated their senior class. So you'll see a lot of them in the pictures. We came back 2 hours and 15 minutes later. His crew had already excavated the bones that they immediately encountered. It turns out that was only the first of 3 separate piles of bones there. But as soon as I saw this, these are mastodon teeth. So I knew it was a mastodon. There's the tusks that had been broken off. So the skull was in this pile. One of the shoulder blades was in the pile. One of the rear legs was in the pile. And a few other bones, and I'll point these out later. On the right are some of the guys from the Joint Vocational School. And so what we tried to do, what we knew is that these bones were saturated with water and that this is a below 0 environment. So if we set them up for very long, they would freeze, the water in them would freeze, it would expand, crack, damage the bone. So our first priority was to get those bones wrapped up in wet burlap, sometimes put in boxes if we had a box that would fit in, wrapped up in something though, and loaded in the back of the pickup or the flatbed truck, and taken to the tuberculosis sanitarium to be deposited in the lab. And that was the first part of that. So this load got loaded up and took off, and then we began to look to see what else we might find. So mastodons and mammoths. That's a mastodon on the left, mammoth on the right. They have very different teeth, and it's because they have a very different ancestry. In spite of the fact that they look so similar, their last common ancestor lived about 37 million years ago. So I'm more closely related to a chimpanzee than mastodons are related to mammoths. But mammoths are elephants. They're the elephant family. So here's the elephant family, and here's woolly mammoths. This is the mastodon. Like I say, this is where their last common ancestor diverged. And mastodons are a little bit smaller. They're not as high in the shoulder. Their tusks tend to be not quite as long and curvy. And they don't have sort of that little dome on the head that the mammoths have. This is a map from the Ohio Department of Natural Resources showing where mammoths, mastodons, and indeterminate. So they've got a big bone, but they don't know whether it's a mammoth or a mastodon. And the circles are mastodons. So right away you can tell that there are more mastodons in Ohio than there are mammoths. If we went to Nebraska, you'd see the same pattern, but it would be reversed. There are many more mammoths in Nebraska than there are mastodons. So this is telling us something about their adaptations, their diet. Mastodons tend to be browsers on a variety of foods. We now know a variety of foods. At the time, most archaeologists and paleontologists thought they were mostly eating spruce. But then mammoths are more grazers, eating grassland vegetation. And in Nebraska, even 2,000 or 10,000 years ago, there's still more grass than trees. So that's why the mammoths were happier out there, mastodons were happier here. So when I'm confronted with this mastodon, okay, and we have got 2 days, but I'm thinking we have to dig it up now. Already, we knew we could not do an archaeological excavation with all the care and caution, mapping in everything and taking stuff out. We knew it was going to be a salvage excavation. And I wasn't happy about it, but I didn't have to be happy about it. It was that or nothing. And I just thought we had an opportunity to do something here that would contribute to our knowledge of these creatures and perhaps humans. But basically what we had imagined, based on the context, it's this bones in the middle of a pond, that it was probably a mastodon who'd fallen through the ice and drowned and sank to the bottom, so that we were, in effect, salvaging a paleontological specimen and not conducting an archaeological excavation. Now, over the course of those 2 days, if I'd had 5 minutes to think about what I was seeing, what was coming out of the ground, that assumption would have been challenged numerous times during the course of those 2 days. But I didn't. But when we started doing the analysis later, it's like, this isn't what we thought. So, is that the way the mastodon died or not? Here's day 1 when I'm just wearing a ball cap. Next to me is my colleague, Dr. Todd Folking, a soil scientist, geomorphologist from Denison. We called everybody we could. I've never, ever excavated in a Paleo-Indian site with such incredible preservation. And the bones, beautifully preserved, but they were all tan brown by the acids and plant acids and things in the water. Other than that, though, they were like pristine bones. We found beaver-gnawed wood. We found pine cones, spruce cones. And on the right, there's a leaf. I found 2 of those that were green when I exposed them. That was one of them. Huh. It's not now, did I? Oh yeah, that's kind of what it looks like. I don't know what kind of species it was, but it looks very much like that. And actually, this is a bit of a diversion, a bit of a digression, but it plays into later. So I find this, I exposed this green leaf. I had one further, but it turned brown pretty rapidly. So I'm going to take a picture of this. Of course, I'm in this muck that's like more than ankle deep, and in some places even more than that. So I didn't have my camera with me, because if I dropped it, it might have disappeared forever. So I had it in a milk crate on the side of the excavation. So I'm like, I'm going to take a picture of this, wade through the muck, take my gloves off, immediately my hands start freezing, pick up the camera, wade back through the muck, open the lens cap, put it in my pocket carefully, get ready, and it's already turned brown. Oh. I'm like, okay, take a picture anyway. Took the picture, put the thing back on. My hands are numb by this point. Get back to put the thing away, try and get my gloves back on. Go back, start working again. Okay, so the lesson there is taking a picture was a big deal. There comes a time when I don't take a picture, but I really should have, because, anyway, we'll get there. But amazing, amazing preservation. Even more amazing, you'll find out, than this. We had media come into the site both days. This is Channel 10, and it was eventually aired on CNN. And it was hilarious because who was it? Kurt Ludlow, the meteorologist from Channel 10. And he's out there, comes out in a helicopter, and he's like wearing this Italian suit, and a big coat and nice shoes. And he's standing on the edge. They wired me for sound and had me down there. He says, "What's it like down there?" And of course, what I wanted to say was, "Why don't you come down here and find out?" But I didn't. I smiled and I said, "It's incredible. It's the closest you could come to a time machine to the Ice Age." And they interviewed me a little bit more, but that was the soundbite they used. And that showed up on CNN, so that was kind of cool. This is the second cluster of bones that Todd Folking and I were starting to work on in that other picture. So what we found here you can see a bunch of ribs, and there were a lot of ribs there, but there were also the thoracic vertebrae that the ribs attached to. And those are, you can just see sort of heads of the vertebrae coming out of there. And this is one of 2 times when I got to use a trowel. Because what I wanted to find was the surface on which the bones were resting. And then that's what I've got down here in the bottom. And those white things that are not bone, those are spruce wood. Because I was collecting those from the layer at which the mastodon was found to use for radiocarbon dating. Later you'll see the dates that came out, actually, because later we dated the bone too. Those dates were much older than the mastodon. And it makes perfect sense though, because when I put my foot down, I probably went back 1,000 years or something. So the mastodon settled down into these older deposits. Here's cluster 3. This is the second day, you can tell because I've got my Cleveland Browns wool cap on instead of my Cleveland Indians baseball cap and long underwear. Here we're working on the third and last cluster of bones. And this cluster included the front limbs, including the hands and the few fingers we found, and the cervical vertebrae, the neck vertebrae, in a stack upside down. And this is all, if that stack was here, the mastodon was probably found where the table of stuff is. That's where the skull and the pelvis and the other things are found. And then the other cluster was found over there where that speaker system is out there. So, they were about that far apart, 3 discrete piles of bones. And here, we were using rebar to push down into the soft peat, and then if plunk, if it hit something, it was a bone. And we determined that we couldn't find any bones anywhere else but in those 3 clusters. So here, if I had 5 minutes to think, why, if this animal has fallen through into this shallow water pond with no streams running through it, it was a very low energy environment, why should these bones be in 3 discrete piles? With the neck here, so the head should be at the bottom of that, if it was where it's supposed to be, but the head is actually like over there. But of course, I'm not thinking, I'm just retrieving, I'm salvaging these materials for study later. So this is when I got Dr. Dan Fisher from the University of Michigan involved. So we get there out the last day. The next day I'm calling him on the phone and saying, Dr. Fisher, we met at a conference, so we kind of knew each other. And I said, we've got this mastodon. Help, what should we do? And he was telling us that we had to rotate the bones every few hours. Because if you just let them sit, even in a warm environment, the water starts evaporating up, and it starts opening up vents to vent, and the longer you leave it, the bigger the vents get. So you got to rotate it so it finds new ways to get out without making big cracks. So we were doing that every 3 or 4 hours, sort of like having a kid. And we had crews lined up with volunteers going to the tuberculosis sanitarium in the middle of the night, which I did several times during those weeks. And one of those times was funny because there's this old guy cleaning up the place in the middle of the night. And he's telling me stories like, that stairwell over there, one of the residents here hanged himself in there. And I'm like, I don't want to know this. I don't want to. There's funny sounds in the building all the time. I don't want to know. Does it bite me with a ghost in there? Oh, I don't. So this was created by Dan Fisher using only the slides we took. Because I didn't explain that either. So we couldn't record everything. But every time we found bones, we exposed them, took pictures of them in place, and then pulled the bones, wrapped them up, and shipped them back off to the lab. So it was a pretty rough way to do it, but it did allow us to document associations of bones, but it wasn't perfect, because there are lots of bones we have that don't show up in these graphs. But Dan used our photographs, he used video that other people were taking, like the golf course owner, and this is what he identified as the 3 clusters and the bones in them based on both photography. But I know, for example, that for cluster 3, these are the upper arm bones. I know the other bones were there too, and the feet were there too. Our photography here was limited because this was like a wall of earth and there was like part of the water over here. And as we're excavating, water starts dribbling out of the walls. So we were worried that if we took too long, that was going to bust like a dam, flood the excavation. So we took those pictures and then just hurriedly pulled things out. And where the feet were, I found some toes, but it's not, a lot of the toes you'll see in the next picture are missing. And it wasn't because they weren't there. Because I personally excavated the feet, and I was doing it with my hands, with rubber gloves. So I was feeling around in the muck. Mastodon toes aren't so small that you might miss them. I mean, they're quite large. So if they were there, I would have found them. But they weren't there. It's another thing that should have, like, what happened to the toes? This is Dan's, what he calls his roadkill diagram. So you're driving in your Volkswagen down the street, Mastodon comes up in front of you, you run over it, it's spread out, and then it's color-coded by the 3 different clusters. So red is the first cluster, which has the extreme rear end and the extreme front end of the mastodon, and none of the in-between elements. The skull is sitting on top of the pelvis. It's got one of the arms here, one of the rear legs. Actually had both shoulder blades, it turns out. I said one. If it's blue, that's the second cluster that I was excavating with Todd Polking. Almost all the ribs came out there. So we just didn't get enough of a picture there. But most of the ribs here that are indicated as blue are from that. And then the green is the third cluster. So bones from widely different parts of the mastodon are found separately in these 3 different piles. And what's colored in brown are bones we have in the collection that just don't appear in a photograph. So all we're missing most of the toes, we're missing the right rear leg, although we have the right kneecap, and we're missing the left kneecap. And that's basically it. Missing one or two tail bones. So we have like 90% or more of the skeleton separated into 3 piles. Now this is cool because Dan asks us, he's helping us preserve things, and he's telling us about rotating the other bones. He says the tusks are different. The tusks are really hard because they grow like a tree and add rings over the years. And he said, and it's not just like a tree, because you can't cut it anywhere and sort of count the rings. It's like you've got the place where the tusk is growing. It's like shoving an ice cream cone in there, and then shoving another ice cream cone in, and another ice cream cone in, and another ice cream cone in, and it pushes it out. So what he said, because of those rings, and because if you just let those dry, he says the outer layers dry, crack, and sometimes even spall off, and then the next layer dries and cracks and spalls off. And he said he's found that the best thing to do is right away cut the tusk in half along its long axis there. And then you let it dry from the inside out. And then when you're ready to go, you glue it back together, and there's no warping or anything, so they just fit right back together. He said the other thing that allows you to do is you can see in the layers the whole course of the mastodon's life. So this is pointing to, this is one little section polished of the inside of the tusk. The dark layers are like winters, but it's not getting that much food. And the light layers are like autumn, spring, summer, and they're wider, and he's growing faster. The top is the interior of the pulp cavity. So that's when the animal died. That shows he died just at the end of an autumn, like just before winter starts. So he didn't die, he didn't freeze to death, die of starvation in a very terrible part of the season. He died in sort of just late autumn. He was about, I can't remember exactly, like 25, 27 years old. Dan said he was a mature male, but not an older male. And the stories he can tell from looking at these rings, he can tell for this male, and that it was apparently just like elephants. When elephants mature, the males get thrown out of the herd once they reach reproductive maturity and becoming a problem. And they have to live alone for a while until they find a mate. And then they mate, and then the mate kicks them out. But it shows up in the curves as when he reaches his late adolescence, he goes through a couple of bad seasons where he's starving. Other times, his mom and aunts and things were taking care of him and feeding him the food. He's on his own for those years, and he's living hard, so he's not growing as much. But then later, he gets his own, starts eating stuff, knows what to do on his own, and it's fine. But it's even cooler, he says, when you look at a female. Because with a female, you can tell, first of all, when she gets pregnant, and then if that calf is born, when you can see when that happens, and then you can find when the calf is weaned. And so you can tell if the calf dies before he's weaned, or she is weaned. Because it's all showing up in the growth rings in the mastodon groups, their entire life history. And it's this way with elephants too. So you can tell us a whole lot about this animal's life. The season it died, like within a couple of weeks, how old he was, his whole life history, which was kind of neat. So, and he said, don't scrub the bones with brushes. There might be meaningful marks on the bones. You don't want to distort them. You don't want to make your own marks. So hose them off lightly. And we did that. And in that process, these are some of the ribs. We found a bunch of, that's a close-up of this. You can look at the same one over there. And these are like gouges of some kind. They're pretty wide, they're pretty shallow. We were getting excited when we found this because we thought maybe they were butchering marks. And they might be if they're using something like a big flint cleaver or something. But it's also possible they could be carnivore tooth marks. And like if the Paleoindians had dogs with them. I don't know if any of you have seen this old classic video that they showed us in anthropology, Nanook of the North. There's a scene where I think he's butchering a seal or walrus or something big, and he's constantly kicking his dogs out of the way because they're trying to get in and get something to eat too. He's like, oh, get out of here, I'm trying to do this. And I can see dogs, Paleoindian dogs, doing that. They got this giant mammoth carcass who got cut up into bits, and they're running in trying to get some too. This, however, this is the ring finger on the front limb. It's one of the only complete fingers we have. And these are two really distinct, narrow, tightly V-shaped grooves. And I think and thought at the time when I first saw them that they were stone tool cut marks. This is a scanning electron microscope of one of them, and they match a stone tool cut mark. And I'll talk about the other one in a second. And Dan thinks, based on things he's seen in other mastodons, the Paleoindians have killed the animal or come across a dead animal. They're cutting the tendons for the fingers, and then using the fingers to help pull the hide off. And he says that's why they're mostly missing the fingers. This one finger we have left has these two deep striations of cut marks where it could have been used for severing the tendon. Now, while he's looking at some of the bones with the scanning electron microscope, he finds that, which is a pattern of mostly one direction drag marks. So that bone has been exposed, it's being dragged across a sandy or gravelly surface and leaving a bunch of parallel scratches on it. This is one of the scapular epiphyses for the shoulder blade. So many of the bones, just like human bones, they're not completely fused until the animal gets older. You can actually tell how old an animal is by what epiphyses, and this works in humans too, have fused and what haven't. This one was like partially attached. It came off during the excavation. You see it's got all these nooks and crannies. That helps it fit together and fuse tightly with the other bone. But in this case, it's become separated. And it had all this black peat caked into it, and it wouldn't all rinse off, so we didn't want to scrub it, so we just left it there. Over time, that black peat dried and peeled away, and in many of the holes we found sand and some coarse gravel, or I guess very fine gravel, not coarse gravel. It would have been coarse sand. There was no sand or gravel in the bog. Is this starting to sound like CSI, Ohio? Yeah, it's like a forensic case. So this animal initially was dead somewhere else, not in the lake, not in the pond, somewhere where there was a sandy environment, where the sand got stuck to the bloody insides of this bone. Some of the bones got scratched by the sand and gravel as the parts were being dragged into the bog. So yeah, that's what we think happened. And this is cool because this was a diorama made for the Ohio History Connection before the Burning Tree Mastodon was ever discovered. And guy sitting on top of the ribs with his cleaver might have been leaving the same kind of marks we found on the ribs. These people back here are busting up one of the rear legs for the marrow, probably. That may be why we don't have one of the rear legs, because it got all busted up for the marrow to feed the hunters at the time. They're trying to save as much meat as they can. But still, there's this nagging question. Why are people risking their lives to hunt these critters? And the burning tree mastodon is like an answer to that. Because it's like an ice age meat freezer. They can kill a mastodon, cut it up and put it in a pond, and come back to that pond all winter. So you've got a source of meat to feed your families, even if it's your small group, all winter. It allows that food source to have a huge, much longer use life than it normally could have. There's Dan Fisher, and he wanted to test this hypothesis. And one of his colleagues at the University of Michigan had a big draft horse. Her name was Mona. She had a long, happy life, died of natural causes, and her body was donated to science. And Dan used stone tools to cut her up into segments, and then he went to some ponds in Michigan and submerged the bones into these couple different ponds that he was using. As we're developing this argument, or as Dan was developing this argument about why he thought this animal had been killed and butchered by Paleo-Indians, I'm still the skeptic who thinks Paleo-Indians wouldn't have hunted these guys very often. It would be stupid. And so I'm being dragged along going, no, this can't be happening. Who's going to go with that? Oh, it's left now. Anyway, so he's saying, okay, I remember, because I said, I didn't mention that yet. No wonder I'm out of sequence here. As part of the excavation, and I think I was supposed to talk about it in the other slide, or maybe it's not that slide. When we were excavating the ribs, this was a really cool thing, because this was the other time I got my trowel out. I'd read about other mastodons from the 1950s, 1960s that were excavated, where they found masses of chewed up spruce branches associated. And that's where they decided that mastodons ate spruce branches. And that was like the gut contents or the stomach contents. And so in excavating the ribs, I'm going, hey, let's look and see if we can find that. We'll get a chance to look at their diet. And after this week, I was carefully troweling everything, and I didn't find a big mass of chewed up spruce branches. Instead, I found in this black, coarse peat a stripe, not that wide, not that long, of reddish brown, real fine stuff. And it smelled like a soup. And I'm looking at it, I troweled that, and it's like, that's not a big mass. What is this? I said, Todd, come here. I said, what do you think that is? And he said, I don't know, it could be rotting, it's anything rotting here in this log. And I took a scoop of it on the trowel and put it under his nose, and I said, well, smell it. And he goes, oh, geez, who knows? And then I'm looking at it, look over at my camera. And I look back down on it, it's like, well, he doesn't think it's anything. All right, we're at least going to save some. So I grabbed some Ziploc bags, sampled it out, and it all came out in kind of like a tube. And I filled up several bags, set them on the edge of the excavation, and went back to work. Didn't take a picture of that, that's right. At the end of the day, we're loading up the truck, getting ready to go, oh, those samples. I run back, they're frozen solid, they're like rocks. I'm like, oh crap, and we take these back to the lab, they're just going to thaw out and probably get mildewed and ruined before we get a chance to look at them. And one of the volunteers said, I got a freezer in the fridge that I use for deer meat, we can just put them in there. It's like, awesome. So then I don't think about it for another several months. These slides might show up later, but I'll go ahead and finish the story now. No, I'll wait. I'm sure I've got these slides. These are Clovis points that we did not find with the burning tree mastodon. But I was teaching part-time at Denison at the same time, each evening classes, and I had a student up working with us that she got really excited about the project, and she went to all the local farmers around this and was looking at their farm collections. And in one of them, like in one cigar box with a few other things, there were these 3 Clovis points. Could these be the points that killed the burning tree mastodon? Did that mark the kill site and then they cut it and dragged it? Maybe. but the Clovis period lasts 500 years or something. So these might have been used for hunting deer, 100 years previous or 100 years later. We'll probably never know. We couldn't test them for blood residue because, first of all, we didn't think about it because we didn't own them. I've never seen them in person. I just saw the pictures that the woman took for us. But anyway, maybe. Oh yeah, here's where I was supposed to talk all about that. Because this is the article, one of the articles that talks about how the mastodons ate spruce. And this is us exposing the ribs, and this is the area where that brown, or that reddish-brown stripe showed up. So we sent samples of it to a paleoethnobotanist. She identified spruce twigs, needles and barks, grass, sedge, pondweed, water lily, moss. This is some kind of deciduous, brushy plant. So apparently eating like a modern moose. All these rich foods, not just spruce branches. So I personally think the mastodons were found with spruce in their guts were mastodons that died in the middle of winter and didn't have anything else to eat, were just putting stuff in their stomachs and maybe starved to death. This is the kind of food that helps build strong bodies 12 ways for mastodons. And then, a couple months later, this is Dr. John Sanger from Ohio Wesleyan University. He's a paleolimnologist, so he studies the evolution of ancient lakes. And he wanted to come out and put a core in. And at the time we thought, no, the whole thing's been dug up. But we took him out there, and there were corners that still had the bog in place, and the owner said, yeah, he could do whatever he wanted. So here he and his students are putting cores in. And they had the cores to take back to their lab, but then I said, do you want to come and see the bones? They said, sure. So we took him to the tuberculosis sanitarium, and we're showing the bones. And I start telling him this story about the guts. And it was that scruffy-looking guy in the back, raised his hand, and I said, yeah. He said, well, if you think these are like the gut contents, have you looked for bacteria? I said, no, you have to understand, these are like 13,000 years old. There's not going to be any bacteria. And he said, well, I'm Dr. Jerry Goldstein, I'm a microbiologist. There could be. What did you do with the samples? I said, well, they froze. He said, did you keep them frozen? And I said, yeah. He said, perfect. If you'd done anything else, if they dried out, he couldn't look for bacteria, but now he can. He says, can I take a sample? He said, sure. This is what the environment would think looked like, just pretty much like cedar bog. And this is Jerry Goldstein. He think it's from the guts. He resurrects Enterobacter cloaca from the samples he had, puts them in a petri dish, these bacteria grow. They only live in animal intestines. We're pretty excited. That picture on the right is at the news conference. It had all the big newspapers there with the picture that we had provided from another lab. And finding living mastodons, bacteria from the stomach, finding a mastodon that might have been killed by Paleo-Indians. This was big news back then. This is New York Times, London Daily Telegraph, National Geographic that came later. Discover magazine made us one of the top 50 science discoveries of 1991. It's right there between homosexual brains and the 4,000-year-old man. So that was pretty cool. So then Dan says he's excavated another mastodon, has gut contents. His stuff is being studied by the Center for Microbial Ecology at Michigan State, one of the top institutions that does this stuff in the world. He says, can we have some of the samples? I say, sure. These guys find many more species of bacteria that only live in animal intestines. We also gave them some peat samples that we'd saved, for who knows why we'd saved those. They found bacteria in those, but only bacteria that live in fresh water. So this categorically demonstrates that what we found were the mastodon's intestines. We know more about what mastodons ate now than we knew before. We revived bacteria. For a short period of time, the burning tree mastodon was in the Guinness Book of World Records for having the oldest living creatures in the world. And we were beat out later by somebody that had a bee in amber, and they drilled into the bee's guts and found intestinal bacteria from the bee that was 1 million years old or something. So yeah, that beats 13,000. But for a while, We were right there. This is where the burning tree mastodon now resides, at the Kanagawa Prefectural Museum in Yokohama, Japan. It was the owner's private property. He allowed us 2 years to do whatever we wanted. We did radiocarbon dates, we did all kinds of things, we did these studies with the guts, but he said, nope, he's going to sell it. The most any mastodon had sold for before then was like $40,000. The Licking County Historical Society said, we'll give you $40,000 for it, we'll build a museum to put it in. And he's like, no, I'm going to get $1 million. You kidding? My team and I made it famous. So of course, so what he did, he took it to a fossil show in Tucson. Do I have that slide? No. I had a picture of an article from the Wall Street Journal where he took it to this fossil auction, and 2 countries got in a bidding war, Germany and Japan, ironically. And Japan gave him, I was told $600,000, but he claimed it was more than that. But it wasn't $1 million. But he did all right. And on the one hand, it's kind of cool having an international museum want this specimen. They were building this was like a proboscidean hall where they were going to show the evolution of elephants and related animals. And this famous specimen was cool. And they were going to mount the skeleton, but Sherm was in the business of casting the skeleton and selling casts of it. So he said he'd give them a cast or something, and because they could display that and then not have to drill holes in the actual specimen. So they did that. So that's a cast replica. There's one just like it at the Creation Museum in Kentucky of the burning tree mastodon. And we have parts of them at the Fort Ancient Museum, the skull and the tusks we have on display there. So those casts have gone all kinds of places. But that's where the actual skeleton resides, and if we wanted to keep studying it, that's where we'd have to go. So yeah, did Paleo-Indians actually drive mastodons and the other Ice Age animals to extinction? And it's like, now I think they had a role to play. Certainly the climate change is sort of tipping things against the megafauna. But if Paleo-Indians, even if they're just hunting, one family group, one little band hunts one mastodon a year, right before winter, and kills that mastodon, and has those remains to feed them all winter, and every one of the little bands hunts one mastodon. That's probably enough in a stressed species that's already on its way towards extinction to tip the balance. Because they have such a long gestation period, they don't replace the population as fast as we do. So, yeah, maybe. And maybe this was enough to tip the scales. So that with these new data, with this new idea, it was enough to tip the scales for me to say, yeah, people probably were involved. And so here I've got the original slide there of the cutting it up. And this is actually from a different exhibit that I think I saw in Colorado, showing people dragging the meat out and putting it in the pond. But yeah, no cliffs like that here in Licking County. So the ability to cache meat in ponds for long periods of time, they've changed the risk-benefit equation enough to tip that balance. That concludes my formal presentation. I'll have to open it up for questions and answers. But first of all, thank you all. Thank the Friends of Hopewell Culture National Historical Park for inviting me to be here. And thanks to Ohio Humanities for helping to sponsor the event.
So, if humans tip the balance for mastodons, were they also consuming all the other large animals? I mean,
I don't think so. But in Africa, elephants are like a keystone species. So they modify the environment so much from tearing crap up that a lot of other species depend on their modifications to the environment to live. And so the keystone species is like you take the keystone species out and the wall falls down. So it may be that a lot of these other animals depended on the ecological chain based on the modifications to the environment that the elephants were doing, or the mastodons in this case. And because the mastodons are out of the equation, it's like a domino effect that affects the whole ecosystem. I mean, that's one of the ways I've been thinking about this. But no, there's evidence that Paleo Indians hunted some of the other Ice Age animals, but certainly not the big carnivores. They weren't hunting short-faced bears. If anything, short-faced bears were hunting them. And some of the other species don't seem to be connected. But if the whole ecosystem gets messed up because of changing environments, but also because the elephants are no longer there, or the relatives of the elephants, I should say, that could have caused that cascade. That could have contributed to a bunch of other extinctions. Yeah?
How did, I feel sad that the bones are in Japan. How did some millionaire come and buy that? How did they go away?
It was
How long did you get to keep them?
The owner gave them to it. Well, we kept them in storage for 2 years, and the owner approved any testing that we wanted to do. We did destructive radiocarbon test dating on some of the bones, which allowed us to establish the age, and it's right around 13,000 years ago, as you might have expected. People were involved, and do these other tests with the gut contents and things. And he just sort of sat back for 2 years and let us do what we wanted. And we were all expecting it to be donated, or it to be sold to the Licking County Historical Society that was going to give them big money, and that we could, all these things would just go on. But he thought he had a big score, and it turned out he was right. I mean, so for a businessman, yeah, he got more than $40,000. He got a big score. They later did it wasn't probably television, some cable show did a show on all people who got these fortuitous big events in their life where they got a whole bunch of money. They did an episode about him. And I actually had a little tiny appearance on that, and met Sherm again for the first time in years. Sherm Byers was the guy's name. He came up to me sort of in between the interviews and he said, "I wish now I'd given you more time." And it's like, thanks. I don't know now.
Too late now.
But it was nice that he expressed a tiny bit of remorse. And he could have given a donation or something from his, but he didn't. Yeah, good question.
Can you elaborate a little bit more on the researcher who placed the draft horse sections in the pond water? What was the result?
Oh, yeah. I don't know not to do the rest of that. It's when you get old, you forget things. Yeah, Dan did that, and he came back every month to test them. And he said after a year, they were still edible. For a full year. He said his wife wouldn't actually let him eat it. But he tested it, and it was edible. He says by the time it was a year old, it had developed kind of a rind. And you just had to cut the rind off, and then it was just fine. And he didn't test it after a year, because once he figured that it worked for a year, you can get yourself another Mastodon at the end. You don't have to worry about it. There were questions about why so much of this cache is still there. And it may be that it was a mild winter. It may be that they could hunt fresh meat without having to rely on the cache. It may be, and this was the other thing. Yeah, because when I was talking about my argument, trying to convince it, this is when I was saying, no, it had to be something else. Because I was convinced, I can overrule your argument, Dan. There's a big chunk of intestine associated with this cache. When you hunt an animal, and the first thing you do is gut it, so you don't contaminate the meat with this stuff. And he's going, okay, that's a really good point. He says one thing is it's only a little chunk of intestines. If it was all the intestines, it would have filled like 4 wheelbarrows full. So he says, why would there be a little chunk of intestines associated with this meat? So he said, let's find out. So one of the caches he had with Mona, he took Mona's intestines, tied the ends off, and put it with the cache. And this is really a cool story, and I don't know what happened. The gas started to build up in it, and it blew up into a balloon, popped up to the surface. And it kept the cache from freezing over. So when he was collecting his samples, he'd have to go over and push the balloon aside and pull out the meat to test. His other caches, he had to go out with steel chisels and poke a hole in the ice and then go in. And it also, not only did it keep the ice free, it marked exactly where the cache was. Dan didn't have to put a stake that would stick up. So for Paleo Indians, if they figured out that would happen, it would mark their cache, it would keep it from freezing over, they could come back all they wanted. So maybe what happened, and maybe the reason they lost the cache was the bubble was there and some small, raccoon or something came and bit it and popped the balloon and it sank and it froze over. And then they're like, where's our cache? That may be why it got preserved. So thank you for asking that question, because now I can fill in the other blank I left in my presentation. Yes?
Is there ever a discovery or an instance where they can't sell it? I mean, it has to be, say, like eminent domain type of a thing?
That can't happen with private property. I mean, when it's like, it's found on my land, it's mine. In every other industrialized country in the world, the museum can come in and say, we're going to take it, we'll reimburse you fair market value for it. Because this is important to science, it's important to the country, whatever. United States, private property is paramount. It's my private property, you can have it when you pull it from my cold dead fingers. Yeah. So no, there was no possibility that we couldn't have it if the owner didn't give it to us. And he wanted to sell it for big money, and did. Yeah.
With the ice cap retreating and the climate warming, is it possible that there was more diseases or bacteria that they could have gotten that caused some of the extinction?
Possibly. It's really harder to prove that. Certainly the bacteria that we found would have been good for the mastodon. Although, years later, I was reading in the Columbus Dispatch, and there was a woman, amazingly I remember her name, Elena Pekuda. She was a NASA researcher who was looking in glacial ice in Greenland for surviving bacteria. And the reason for that is because she wants to someday look for bacteria on Mars. And if it's frozen in the ice, maybe she can resurrect that. And she was finding 8,000-year-old bacteria living from these ice samples that she had. And the dispatch article said that no one of her colleagues were believing her. And it's like, oh, you're kidding, it can't be that. And I'm like, didn't they read our paper? 15,000-year-old? So I found her email address, I sent her an email. I said, we had this. And she said, really? I'd love to see the paper. So I sent her the paper. She writes back and says something like, wow, that's really cool. Some of those bacteria, though, they're pretty nasty. I'm not allowed to grow them in my lab. Would you have some kind of biohazard alert? No. I did stick a trowelful of the sample under a friend's nose and told him to sniff it. And we're okay. He hasn't died yet. But, so, yeah, there is sort of that potential, but wouldn't have been harmful to the mastodon. We've got bacteria in our guts, too.
Could it come from the people at that time? Transferable?
That's a possibility. I mean, Paleo-Indians introduced dogs to the New World, so maybe the dogs had something. Certainly, in record of human migrations, people introducing new diseases to environments where those diseases aren't there can have very devastating effects. And people have speculated on that as being one of the possible causes for the megafauna, but there's just no evidence for it yet. It's just something like, well, if there were new germs, well, yeah, but show me the new germs. Another question? Yes, sir.
Is there any evidence of that bacteria? Has that been found in other sites?
Yes, Dan Fisher found the same suite of bacteria in the mastodon from Michigan. He found, I can't remember the name of it. But that's when he invited us to submit samples to the Center for Microbial Ecology at Michigan State, because he was doing that. And yeah, they published a paper showing, yep, they have the same suite of bacteria in both mastodons.
Any others in Ohio?
Nobody's ever looked, I don't know that even a mastodon has been found with that level of preservation since then. That was really remarkably unusual to find the intestinal remains. I mean, the intestines didn't preserve. There was no animal tissue, but it was just this mold of the intestines that had settled into the peat. So the peat's right up against it, and the intestines have simply decomposed, but the whole column of that intestinal material was still there.
How big a piece would you say that was?
It's about that long, about that thick. And I'm guessing because I didn't even take measurements. I didn't take a picture. I just took samples. So I wish I could say exactly what the dimensions of that were. I wish I had a picture. Would have made the whole thing tighter. All right. Well, thank you all. Oh, one more question.
One more.
No, great.
if I wanted to read more about this, you could give me some
Yeah,
places that I could find information.
Yeah, I've got, we basically have two big articles about the vertex tree mastodon, and they're both available on my academia page. So academia is like a web page for scholars where they can put their articles out there. And if you go to Brad Lepper, academia, it'll take you to the page and it lists all these papers I've got on there that you can download for free. And one of them is the paper. Oh, I shouldn't go into this because this is scholarly nitpicking. But some people will appreciate this. We sent the paper first to science. We've got 7 different disciplines represented as co-authors of this paper. We have gut contents rediscovered for the first time. The editor of Science does not even peer review it, rejects it out of hand. So we're like, what the hell? So we send it to Nature. Same thing happens. They don't peer review it. They just say, this isn't of sufficiently general interest. I'm looking at the contents of Nature and Science. I can't understand 3/4 of the articles at all, what they're talking about. This becomes Discover Magazine's top science story, one of the top science stories, not of sufficiently general interest. They just didn't believe it. So I called, the next level of journal was quaternary research. And I call the editor and I explain this, and I say, will you at least peer review it? And he's going, yeah, sure, that sounds cool, we'll peer review it. And they published it. And quaternary research is well respected at journal. So that was the first publication. And then the other one was an edited volume of Paleo-Indian papers that the Ohio Archaeological Council published. But yeah, I don't usually grouse about peer review because I respect peer review. Even if it's, they're telling me it's inadequate. But these people didn't peer review it. They didn't tell me why it was inadequate. They just said, no, go away.
Wow.
And then when we talked all about it, it's like, we just figured, we just don't believe it. They just think it's ridiculous. It must be contamination. They don't know what they're talking about. They're not Harvard, Yale, big time guys. Ohio. Who cares about Ohio? That's all we can figure. I mean, because if they've gotten several bad peer reviews, okay. Now we know how to improve it. Now we know why you're rejecting it. One more, that's it.
Can you talk a little bit about what's known about actually hunting mastodons, and have they looked at, it seems to me I've read something about looking at traditional societies today and how they hunt, people are still hunting elephants. But when they look at how traditional societies hunt, like elephants today, and apply it to what the Paleo-Indians might have done.
Yeah, the indigenous societies that we know of that hunted elephants and that we have information about are like the Ituri pygmy in Africa. And they're doing it with metal swords. And they're living in a jungle. And they're hiding behind trees. And when the elephant goes by, they come out and hamstring the elephant from behind and then hide behind the tree again. Paleans couldn't do that with a Clovis point. The guy that's done the most work on this is George Frizen, an archaeologist that works out in Wyoming. And he's done a lot of hunting on his own. And his idea is that they threw Clovis points into the guts and then just waited until the animal developed sepsis and died. They just sort of followed it for a couple of days. But all the artistic depictions show guys running up and stabbing it and throwing rocks at it. That's not the way to hunt mastodons. That's the way to get killed. So yeah, George Frizen had, I think, the best idea is that wound it grievously from afar, throwing with a spear thrower, in vulnerable places that will cause infection, and then just wait it out. Okay, well, thank you all very much for coming out.
Please enjoy the following photographs from the Flickr account of James St. John, Senior Lecturer, The Ohio State University, Newark.
Blue Horse Theatre 2025.
Thank you for watching, and we will see you next time.